Today we're going to talk about blood typing, specifically at 3 loci. The first one is the MN locus. This is going to be a codominant locus. What that means is that if you have an M allele and an N allele, both will be expressed. Second locus we're going to talk about is the ABO locus. Now, A and B are codominant, meaning if you have an A allele and a B allele, you will have type AB blood. However, O is recessive to the A and B alleles. So in order for you to have type O, you must have an O and an O allele. Lastly, we're going to talk about the RH locus. This is normal dominance in terms of Mendelian genetics, and the positive is dominant to the negative. The problem we're going to work through today is this one. Basically what this is we are saying the mom has type MNB positive, the child has type MO positive, and we're trying to figure out if the father could be type MNA negative. Let's go ahead and build the mom's red blood cell. We know that the mom is type MN, so she must express both M's and N's. She's type B. We're going to assume she is heterozygous for type B, meaning that she will have a B allele and an O allele, and we know that this has to occur because her child is type O. And lastly, we know that she's positive at the RH locus, so she will have plus signs. Next, we will build the child's red blood cell. We know the child is type M, so he or she will have M alleles only. If they had an N allele, they would be type MN. We know the child is also type O. Again, with that, they have to have only O alleles. If they had an A allele or a B allele, they would not be type O. And lastly, we know that they are positive. Now, they could be heterozygous for that positive RH locus. We don't know that, but let's go ahead and assume that they are. Next, we're going to build the dad's red blood cell. We know that he is type MN, so he will need to have both M and N alleles for that loci. He is also type A. We're going to assume he's heterozygous for type A, so that means he will have one A allele and one O allele. And lastly, he is negative at that RH locus. Now that we know he can only have negative because negative is recessive to the plus or positive allele. So now we're going to work through some Punnett squares. On these, we're going to put the mom's alleles on the top, the dad's alleles on the side. It doesn't really matter, but that's how we're going to do it here. At the first locus, the MN locus, we can see that when you have the mom and the dad crossed, you get one MM offspring, two MN, and one NN. At the second locus, that's the ABO, when you cross the mom and the dad, you get one AB, one type A, one type B, and one type O. Remember with this one, you have codominance with the A and B alleles, and that O is recessive. And then lastly, at that RH locus, when you cross the mom and the dad, you have all of them being positive for this locus. Now, ultimately, the point of this was to figure out if Tim could be the father. So if we go through each of those, we know that the child is type MM, and they have to be MM because they're type M. So that is a possibility. For that one, we are good to go. At that locus, Tim could be the father. Next one, we know that the child is type O. And type O is a possibility of the offspring between Tim and this mother, so that locus is good to go. And then lastly, we're going to look at the RH locus. We know that the offspring or the child is positive, and that's the only outcome for Tim and this mother. So ultimately, you can say, yes, Tim could be the father. It is possible at all 3 loci. However, you cannot say that he for certain is the father because there needs to be more loci in the DNA looked at than just these 3 blood types.